Precalc 1 class that initially did not have an inverse because inverses have to be one-to-one functions, which means one-to-one functions have to pass the horizontal and vertical line test. Vertical to make it a function, and one-to-one means it has to pass a horizontal. So if you all recall from your Precalc 1 class, this is the function f of x is equal to x squared, which we know is a function. But it's not one-to-one. The reason it's not one-to-one is because it doesn't pass the horizontal line test. So what we did, we said, okay, let's make sure this thing is one-to-one. So we restrict the domain. Now, I am choosing the right-hand side, and I'm choosing the right-hand side because it's the easier side to work with. If I choose the left-hand side, that's totally cool too. But if I choose the left-hand side, then when I go to find the inverse of it, I have to make sure I choose the positive or the negative part of it. So the place in which you choose will make a difference. So I take my quadratic and I choose the right-hand side because it's easier to choose the right-hand side. I could have chosen the left-hand side, but it's easier to choose the right-hand side. So with your partners, here's your sine wave. A very bad sine wave. Here's your sine wave. Still not really nice. Think about where you would cut the sine wave to make it easier to make it one-to-one. So here is your sine wave. With your partners, think about where you would cut your sine wave to make it one-to-one. Think about what would be the easiest and which one will be the hardest. I'll give you a minute to talk to your partners. When you're talking about the last one, what does that mean to you? Do what? Okay, so let's if I need to get every possible output value, right? Does this region give me every possible output value? Does that region give me every possible output value? What do you all think? Does that give me every possible output value? Do you think that's the easiest place to cut it? Why, Fred? Why isn't that not the easiest place to cut it? I'm far from the origin. So Lauren, where do you think I want to cut this so I get every possible output value? And it has to pass the horizontal line test. It's okay, you don't know. If you did know, what would you say though? What would you say? So tell me where you want to cut it at. Tell me what you'd like to cut it at. So here? Oh, so you want to cut it again here? It's okay, you don't know. So let me ask you this. If I cut it in those two places, does it pass the horizontal line test? So in those two red places, does it now pass a horizontal line test? Draw a horizontal line. Let's just draw a horizontal line. Does that pass the horizontal line test if I have those two red parts of the graph? So, okay, so what it means to pass a horizontal line test is it means it can only touch the graph once and only once when I draw a horizontal line. So does those two red pieces give me a pass on the horizontal line test, or does it hit it more than once? Well, do I hit it here? Lauren, do you agree I hit it there? You're fine, you're fine. Okay, that's okay. Did I hit the, does my green line hit that red right there? Do I hit it again? Does it pass a horizontal line test? No. So I am going to cut one of these two reds. What do you think, Lauren, will be the easier one to choose? I have two reds, and I agree with the two reds. Which one is going to be the easier one to choose? If you did know. She's like, damn it. So where would you, so if you cut it over here, which is fine. If you cut it over here, this is totally cool. But think about the fact that every time you do inverses, you're going to be looking at negative rotations. Do you think that's going to be easy? So do you think I want to choose that one? Which one do you think I want to choose? The other one. So you knew it. You knew it. So I want to choose this one. So I'm going to choose not this part of the graph. I'm going to take rid of all of that. I'm going to get rid of all of that too. I'm going to choose that part of the graph. I'm going to choose between 0 and pi. Okay? So when I'm cutting my graphs, I choose the ones that are the easiest to choose. Now, if I am choosing for my sine wave to go from negative pi halves to pi halves, where do you think I'm going to take my cosecant from when I cut the cosecant? Josie? The cosecant. If this is my sine wave cut, I'm going to cut my sine wave between negative pi halves and pi halves. Where do you think I'm going to cut my cosecant, who is the reciprocal of sine? Do you think I'm going to cut it differently, or do you think I'm going to cut it in the same place? Yeah. So my cosecant wave is also going to be cut. So here's the cosecant wave in blue. It will also be cut from negative pi halves to pi halves. Jaden, where do you think I'm going to cut my secant wave? Yep. So here's where my cosecant wave is going to be, and it's going to be cut in the same place. Okay? Because they're reciprocals of each other, and it makes sense to have the reciprocals cut in the same places to get every single possible output value and pass the horizontal line test. So here's my tangent. Where do you think I'm going to cut my tangent? Mira? Absolutely. So I am going to cut it from negative pi halves to pi halves. So then my cotangent. Here's my cotangent. Where do you think I'm going to cut my cotangent? Aaron, where am I going to cut it? So you think I'm going to go from negative pi halves to pi halves on this one?
No.
Okay, where do you think I want to cut it then, to make my life easy? From 0 to pi. So we cut it, we're restricting our domain in places that makes it easiest for us to do. So I get rid of these other pieces I don't need. And that way it ensures that it is 1-to-1. Now the important thing is the quadrants. Now remember we took the time to, when we first started graphing it, we talked about quadrants, right? So this pi over 2, I'm going to restrict my cotangent, cosine, and secant between 0 and pi. Which quadrants are those? 1 and 2. So quadrant 1 and quadrant 2. My tangent, my sine and cosecant get restricted between negative pi over 2 and pi over 2. Which quadrants are those? 1 and 4. So I'm in quadrant 1 and I'm in quadrant 4, but remind yourself that you are going in reverse. And this is terribly important. And the reason this is terribly important is because when we start doing inverses, if I want to find the tangent inverse of, say, negative 1, where is the negative? Where is this negative? Well, tangent is negative answers in quadrant 2 and in quadrant 4. And if you tell me that this is 7 pi over 4, you ask yourself, is that number 7 pi over 4 between negative pi halves and pi halves? Is 7 pi over 4 in the interval between negative pi halves and pi halves? No. It is not 7 pi over 4. It will be a negative pi over 4 because you're in quadrant 4 in reverse. It's terribly important. So let's actually give you the definitions and all the stuff that goes with it. So we all know where we cut it between negative pi halves and pi halves for the sine function. What we know is that our domains become ranges and our ranges become domains. So if the domain of my original function, so the domain of the f of x is going to be, I'm going to cut it between negative pi halves to pi halves. What is my range of my original function? What is the lowest number you're going to get? So my range of my original function is between negative 1 and what's the highest value I'm going to get? This becomes the range of my inverse function. This becomes the domain of my inverse function. Domains become ranges, ranges become domains. Yes? No? Yes?
Can you go back over the part where you were talking about the tangent in quadrant 4?
We're gonna, actually, I will, but I'm not going to go right now because we're going to cover it again. It was just a preview. Trust me, it's just a preview to start thinking about it. We are definitely covering this over and over and over again. We're going to flog it to death. So I'm going to give you another opportunity to see it today. I promise you. I promise. So this is the beginning of why that tangent inverse of negative 1 was negative pi over 4, because we're getting there. So the domain of my original function, to make sure that it is 1 to 1, is I cut it here and I cut it here. So that represents this part, is what I was saying there. My original function for sine is going to be cut between negative pi halves and pi halves. So from Precalc 1, when we find inverses of our functions, the domains of my original function becomes the range of my inverse, and the range of my original function becomes the domain of my inverse. Okay. So here's what sine looks like. We cut it between negative pi halves to pi halves. There's my domain, there's my range. So my original graph down here is then in pink, and my inverse is in blue. My domains become ranges, my ranges become domains when I do inverses. Because when I have inverses, it says I have the answer, what produced that answer in my original function. We're going to do the same thing when we do our cosine. So we have cosine, and we said that we're going to cut it between 0 and pi. So the domain of cosine, the original function, the domain of cosine, I'm going to subscript it f for the domain of the original function, which is cosine, is going to be restricted between 0 and pi. Immediately, what does that become without any work? The range of my inverse with no work done. The domain of my inverse is going to be the range of my original function. What is the range of my cosine? Negative 1 to 1. Without any work, what does that become? The domain of my inverse. So here's my cut for cosine. And here's what the graphs look like. Pink is the graph of the original function. Blue is the graph of the inverse. Notice on the y-axis for the inverse, we start using pi's, which normally we don't. But when we start talking about inverses, we use pi's. All right. Here is all of the stuff in its glory. If you want to write it down, I will wait a moment. I'll talk about what arc sine means. So when you see arc cosine, or you see arc sine, or arc any tangent, or any trig function, that's this part is what I'm talking about. That is the inverse. So back in the day, it was really expensive to put a superscript, put a power on there. So what they used to do, instead of doing what we're familiar with, is the cosine inverse of x, because it cost a lot of money back in the day when we printed the books back forever ago to put that superscript of a -1 up there. Because it was so expensive, they wrote it as arc cosine. So this arc here means that we are working with an inverse function. And that power right there does not mean it's 1 over. It means we have an inverse function of the cosine. So here are all the values and properties of arc cosine and arc and sine. Is you really want to pay attention to this. These are going to be key when we start doing inverses. Those are really key ideas. So we have this rule that says, when I have my function and I take the composition of my function and its inverse, this had better be x both ways, otherwise they're not truly inverses of each other. The key part about that, though, is if we take a look at this, my very first one here, let me get rid of this part. The key bit here is this. The cosine of the cosine inverse is equal to x, provided the x I have inside, my inner x, has to run between -1 and 1. If I take a look at this one, the arc cosine of cosine equals x, provided, of course, the angle I started out with is between 0 and pi. If it's not between 0 and pi, it doesn't equal x. It's like, what the heck? Okay, so Fred, we're going to hit this again. So I'm going to use this information right here. I have the cosine inverse, which is the arc cosine, of the cosine of 7 pi over 4. Is 7 pi over 4 in the interval between 0 and pi? No. So because this, it's a really bad arrow, this is not an element. It does not belong to 0 to pi. It is not in there. That means this will not equal 7 pi over 4. Does not equal that. So what you have to do is you have to do an intermediate step. The intermediate step is this. Cosine inverse of the cosine of 7 pi over 4. So what is the cosine of 7 pi over 4 on your unit circle? So this is equal to the negative 7 pi over 4? Isn't that square root of 2 over 2? That's okay. Square root of 2 over 2? So this is equal to the square root of 2 over 2, right? 7 pi over 4 square root of 2 over 2. So then you look on your unit circle in quadrants 1 and 2 only. What gives you the answer of square root of 2 over 2 in quadrants 1 and 2 only? So the answer is pi over 4. I only get to be in quadrants 1 and 2 for cosine. It is not going to equal the angle that you start out with necessarily. And that goes to these key points right here. This is terribly important. These key points are terribly important for sine and cosine and all the rest of them. Yes?
Why do you only get to be in quadrant 1 and 2?
So the question is, why do we only have to be in quadrant 1 and 2? You all told me up here I have to cut it between 0, and pi. So that means I'm in quadrant 1 and quadrant 2 only. That's why.
That holds true for all.
So so I have to pay attention to where I'm standing. So when I do the sine, so let's do the sine one. Same kind of deal with the sine. Let me get rid of this. So if I asked you to do the sine inverse of the sine of 7 pi over 4, you ask yourself, is 7 pi over 4 in negative pi halves to pi halves? Is that true? And the answer is no, it is not true. 7 over 4 is not a fraction within negative 1/2 and 1/2. It's not there. That's not true. So what you do is you tell me what the sine of 7 pi over 4 equals. What is the sine of 7 pi over 4? It is negative root 2 over 2. Do you all agree 7 pi over 4 is negative root 2 over 2? Now, in quadrant 4 in reverse, what angle is that? In reverse. Negative pi over 4. Is negative pi over 4 in that interval that I have to restrict it to? Yes. So here's the thing. The ones you have to pay attention to the most, these are the ones you absolutely have to pay attention to the most, are these two. When it is in this form, let me do that, actually, let me do this. When it is in this form here, you absolutely have to pay attention to where you're standing. Notice on those it was not the angle that was there. When it's in this form, when you have the arc on the outside of the composition, you have to pay attention to where you're standing. However, these are freebies. Those two are freebies. Those will always equal x. Those will always equal the angle. Those will always equal the answer. So if my composition is such that my inverse is on the inside, my inner function, I'm good to go. There is no work done. But if it's on the outside, I have to pay attention to it. Question?
So negative pi over 2, that's like where 270 is?
You are going in reverse. So it is terribly important when you're talking about where you're standing is that for this one, you are going in reverse. So you go this way to negative pi over 2, or you go this way to pi over 2. So you are always in reverse. You are going negative angles. You don't tell me 7 pi over 4 is the answer, because 7 pi over 4 is not in negative pi halves to pi halves.
So that's why it has to be quadrant 1 or 4.
Yes, but 4 in reverse. 4 in reverse. I say that because it's terribly important that even though up here the sine of 7 pi over 4 gives me the exact same value as the sine of negative pi over 4, the answer is negative pi over 4. We're going to hit this again and again and again and again. Trust me. So, without a calculator, tell me what these values are. All right. So, let's go to the unit circle again. On the unit circle, I'm going to do the unit circle in red. In the unit circle, this is 3 pi over 2. This 45 is 7 pi over 4. This 30 is 11 pi over 6. This 60 is 5 pi over 3. Do you all agree to that? Okay, so next to your unit circle, what you're going to do is write the ones that you get to use. You don't get to use that, you get to use negative pi 6, because that is in the interval between negative pi halves to pi halves. You don't get 7 pi over 4, you get negative pi over 4, because that's in the interval between negative pi halves and pi halves. You don't get 5 pi over 3, because that's not in the interval from negative pi halves to pi halves, but negative pi over 3 is, because you're in quadrant 4 in reverse. So when you're looking at these, and you're asked to find the arc sine of negative pi over 2, that means we're in quadrant 4 in reverse. That means it's negative pi over 6. Because 11 over 6 is not in the interval between 1/2 and 1/2, negative 1/2 and 1/2. So the answer to the first one is negative pi over 6. Because you're in quadrant 4, but in reverse. You're in the negative angles. You're in the negative angles. Because if you were to graph these, right, we go back up to the sine that we graphed. Let's go way up here to the sine we graphed. Here's the interval I get for sine, right? If I'm looking at the 7 pi, or 11 pi, what was it, 11 pi over 6? Here's where 11 pi over 6 is. Is that in that interval? No. But is negative pi over 6 in that interval? So this is the connection of, remember where we talked about coterminal? Why did we learn coterminal? This is one of the reasons. That the coterminal angle to 11 pi over 6 in the correct quadrant with the correct sign is a negative pi over 6. Those are coterminal. 11 pi over 6 is not in the interval, but the coterminal angle is negative pi over 6, and that's the one we get to use. So it is important to know where you're standing and what you get to have. So going back down here, the cosine is defined between 0 to pi. So the arc cosine answer should be in an interval between 0 and pi. So what would be the arc cosine of negative 1/2? So this is going to equal 2 pi over 3 because that is in the interval between 0 and pi. Now granted, in quadrant 3 also gives me a negative 1/2 when I take the cosine of the angle down there, but that's not in the restricted domain of cosine. Does that make sense? All right, cosine of 0, pi over 2. The sine inverse is square root of 3 over 2. It's positive, so where am I standing? My answer is positive. So where am I standing? Quadrant 1 or 4 in reverse?
4 in reverse.
But my sign is positive here. The answer is positive. Now remember when we're doing inverses, these are answers. So which quadrant am I in? 1. I'm in quadrant 1. So what is my answer for this one? How are we doing? It gets more delicious, by the way. And if you're like, I have no idea what's going on, and I feel like I got hit by a bus, that's okay. This is the first time you're seeing it. That's okay. It is totally okay to have that feeling right now. It's fine. So we talked a little bit about tangent. So we talked a little bit about that earlier for tangent. So here's where we restrict our tangent. Here's the picture. The pink is the original, the blue is the inverse. Notice on this one, my tangent is restricted. This is the original domain for my tangent, so this is the domain of tangent, which means that this is the range of my tangent inverse. This is the range of my tangent. That means this is the domain of my tangent inverse. So that means for my range, since my range is everything, the domain of my inverse will be everything. But my answers are going to be in quadrant 4 in reverse and quadrant 1. Same thing with cotangent. So again, this is terribly, terribly, terribly important. That top one is the one that you care about the most. That's the top one in which you have to move stuff around. So this is the one in which we have to move stuff around to make sure I maintain that negative pi halves to pi halves. If I ask you to do the tangent of the tangent inverse of negative 1, there is no work. It's just negative 1. I don't have to worry about it. It's just negative 1. Okay? So I don't have to worry about this type. When my inner function of my composition is the inverse, I'm good to go. It's whatever that is. So another example of where it's good to go, if I ask for the tangent of the tangent inverse of negative 300, it is negative 300 with no work. No work whatsoever. Now remember, when I'm doing the inverse, I have the answer. So if I'm doing the inverse of anything, it says I have the y value, I have the answer, I have the output, what input produced it. If your inner function is the inverse, there's no work. You just write whatever that x value is, whatever that is inside the inverse. But tangent isn't. So when it's in this form, where my outside function is the inverse, this is one where I have to change stuff around. Okay? So if I wanted you to find the tangent inverse of the tangent of, let me see, 4 pi over 3, this is not going to be 4 pi over 3. How do I know it's not going to be 4 pi over 3? Because that is not in the interval between negative pi halves and pi halves. It is not in there. So do that one, please. Take a moment to do that one. How are we doing? We're just cruising. We're just cruising. Okay. So what I do is I find the tangent inverse of, well, I just evaluate the tangent of 4 pi over 3 is just 1. Right? Because it's a 45, it's in quadrant 3, so the answer is 1. It's a positive 1, right? Oh, it's a 60, so it's a square root, sorry, it's a square root of 3. So, going back to where this belongs, it belongs in quadrant 1 or 4 with negative angles. So it's going to put it back into 1. So what is the answer then? Pi over 3. How are we feeling? All right, so again, we have the cotangent, also kind of do the same thing. Here is the properties for arc tangent and arc cotangent. Remember, I can write this whenever I see arc. I can write these as the tangent inverse. Same thing as arc. The important pieces that you need to pay attention to are these two right here. And right here. These two are terribly, terribly, terribly important. Where's my arc tangent? These two. These two are terribly important as paying attention to where you're standing. You always need to know where you stand to be able to do these correctly. Always need to know where you're standing. Yes?
Mentioning the last one, the negative tan one, how did you get the square root of 3? I understand you got the pi over 3, but I'm understanding you got the...
Okay, so the question is, how did I get the square root of 3? In quadrant number 3, tell me what the sine of 3 pi, was it 4 pi over 3 is?
Root 3 over 2, negative.
And the cosine of 4 pi over 3 is negative 1/2, right? Double negatives make this positive. Root 3 over 2 multiplied by the reciprocal of the denominator is 2 over 1, which is just root 3. Okay? All right. Again, these are terribly, terribly important to know where you're standing. You need to know which quadrant you're laying in. So if you have the arc as the, and when you're doing the composition, if you have the arc of the trig function or the trig function inverse on the inside in cases like this, don't worry, I'll erase that in a minute, that those are the ones you just get the answer. You don't have to do any work. But if it is the other way, which is this one, and this one, that's the one in which you have to do the work. You have to make sure that you land in the right quadrants. You have to land in the right quadrants, or you'll never get the right answer. You have to make sure that you're paying attention. That if your inner function is not the arc of that trig function, you have to pay attention to where you're standing. You have to pay attention to where this thing is defined. All right, how are we doing? Here is the cosecant and secant, the range and the domain. So the domain of the cosecant is restricted to this. This becomes the range of your inverse. That is the range of your inverse. If your cosecant is the range of the absolute value is less than or greater than 1, then that becomes the domain of your inverse. Domains become ranges, ranges become domains. The same thing for the secant. This becomes the inverse range, and this becomes the domain inverse. Because when you have inverses, it says, I have the output, I have the answer, I have the y value. What input, what x value was put in there to get that answer? How are we doing? It gets more interesting. It does get more interesting. Yes?
I'm not so the homework assignment that was due this morning.
Was there something due this morning? Was there something?
On all of this.
Didn't I change the due date on this? Oh, I'll change the due date.
I'm just saying, I kind of figured that, but that's because I knew all this already. I'm just saying.
Oh, yeah. All you have to do is just send me an email and say, hey, could you move the due date because we haven't covered this? I arbitrarily set due dates at the beginning of the quarter. And I thought, oh, we'll be there by this point, which is okay. We're not. It's okay. I just need to know. So, yeah, I'll change the due date. That's all you need to do. That's all.
I'm not asking you to do that. I'm just saying.
I will change the due date when I get back to my office. So if you work on this homework between now and say noon, it's going to mark you as 50%. So please don't work on this part of the homework until after noon so that I can change the due date. Okay, almost done. I know we're almost done, and it's a Friday, and we just want to be done. Did everyone have a chance to write this down? Everyone have a chance to write this down? Now remember, I do have a study session today at noon, at 1 o'clock to 4 o'clock. I'm in the science building in room 101, which is the far away from us corner on this side.
Are you going to record it?
I will try, and I brought my cord so it won't die on me. So if you are inclined to come for that review session or study session or whatever you want to call it, I will answer any kind of question. Now remember, I'm just wasting time because people are still writing this down and I don't want to go on. So I'm just wasting time. So remember, there is a take-home quiz due next week, and there are a number of identities you have to prove on there. So do not wait until the night before it's due because you won't finish. And this is what I promise you, that 5 of those will be on the test. You get to prove 3 of them. I give you 5, you choose the 3 you want to prove. So really pay attention to that homework. Do not copy off of someone else. Now, with that said, I know you all are working together. Right? Everyone here's got a study partner or 2. So for the love of gophers, when you turn that in, put your names on there and just turn in 1. Don't turn in 60 of these things, because I know you're working together. Okay? At most, though, put on 3 names. If you are working alone, that's totally cool. I don't have a problem with that either. But for the love of gophers, I know you all are working together. Just turn in 1 for your group, please, so that I can grade these in a timely manner and get them back to you. Our test should be about Friday of next week. It will cover all of Chapter 10 and 11.1. Have a great weekend if I don't see you later this afternoon.